Okay, in this demonstration, we're going to go ahead and create a Linux shell script and then set it as executable so that we can actually run the script. Now you can either sign into your Kali Linux virtual machine as per step 1 in the exercise directly with username Kali and password of Kali, or if you prefer, you can make sure the SSH daemon is running on Kali Linux. You can do that with the sudo service ssh start command. And what I've done is I've actually run that, and I'm using the PuTTY tool, as we've seen previously, to remotely connect over SSH because I prefer to use this interface. Whether you do this in PuTTY or directly in the Kali Linux VM makes no difference. So let's go to step 2. Step 2 is cd enter to go to the Kali Linux user home directory, which we can verify with print working directory pwd. So there it is, /home/Kali. Now I want to create a script file here, so I'm going to run sudo nano, and I want to call this file scripttest.sh. Nano is the built-in text editor. Now you can either enter the entire script as per step 4 in the exercise, or you can copy it and paste it. Now if you're in Kali Linux in a terminal window, you would open up the edit menu and choose paste clipboard. Here in PuTTY, I can just right-click, I've already copied it. So let's take a look at this script briefly. This isn't about syntax, but very briefly, the first line in our script is telling Linux that we want the interpreter to be bin bash. That means it's a bash shell script. We know that Linux has multiple shells, like Korn shells and C shells. We want this to run in a bash shell because the syntax is specific to that shell. I'm creating a function called showIPinfo. The function declaration begins after the opening curly brace and ends with the closing curly brace. Everything in between defines what that function does. What I'm doing is creating an IP variable, a default gateway variable, and I'm basically running some Linux commands like ifconfig against eth0, piping that to grep and filtering it for some text, translating, basically replacing spaces with colons so that I have a colon between all the pieces of information in that command output. And that lets me specify the fields I want to cut out, like field 3 with a delimiter of a colon. Now that entire statement is within backticks. That's not a single quote, that's a backtick symbol. Normally what you do on your keyboard is you'll press your tilde key towards the upper left to get that symbol. What that means is I actually want to execute the command within the backticks and store the result of the command in the variable. So I'm doing that to get the IP address for IPv4 and IPv6. And I'm doing the same to get the default gateway with the DGW variable. Same type of thing. Then I'm echoing those variables back. And when you actually want to display the contents of a variable, notice that you refer to it with a leading $sign. I'm also displaying some name server information by catting the etc_resolve.conf file. Then I have a while loop, while true. Well, true is always true, so this is going to be executed at least once anyway. And we have do. And all the way down at the bottom, we have done. Everything in between is part of the loop. So what I want to do is clear the screen, and I have a bunch of echo commands echoing some text back, like a utility menu, and 1 to show IP info, and 2 to show currently logged in username, and so on. Now then, I'm using the read command in Linux, which allows user input, and I'm reading whatever the user types in I'm going to put that in a variable called selection. I can call the variable whatever I want, but then I'm testing the variable with the case statement. Again, $sign selection in this case. So if they typed in number 1, then I'm going to run my show_IPinfo function that we declared at the very beginning. If they type in a 2, I'm just going to run the whoami command. And if they type in 3, I'm going to clear the screen and exit out of the loop. Now notice the end of my case statement is the word case spelled backwards. And to pause, I'm just going to use another read command, and I'm just going to call this junk variable. And that's that. That's all there is to it. Okay, so that's our Linux shell script. It's like a little basic utility menu. Shell scripts can do anything. Anything that you can do with the command line can be automated with the shell script. Let's press Control X. It asks to save. I'm going to press Y for yes. It asks the file name to write to. I'll press Enter to accept it. So the next thing we want to do then is go ahead and try to run that script. So if I were to, well, before we do that, actually, let's do an ls. If I do an ls for listing, our script test.sh file is in our current home directory. So therefore, if I do sudo // which means current directory, and the file I want to run is called scripttest.sh, comes back and says command not found. How could it not be found? We just saw it and it's spelled correctly. Well, that's because the script hasn't been flagged as executable. Okay, so just for fun, if I were to run, let's say, ls-l for scripttest.sh, currently the user root, for example, has read write. Okay, but there's no execute, there's no X. So what we're going to do is the following. We're going to change the permissions as per step 7 in the exercise. We're going to run sudo chmod 550 script test.sh. And then I'll explain what that means. Let's just do an ls-l on that file again. Okay, so the first 5 here is a combination of read, that's a value of 4 in Linux, and execute is a value of 1, so 4 plus 1 is 5. That 5 sets the permissions, the first set of permissions here, which maps to the owning user, which in this case is user root. We could change that if we really wanted to. The second set of permissions, which are also 5, so read and execute 4 and 1, maps to the owning group, which is also called root in this case. And the 0 means no permissions for anyone else. Oh, okay. Well, let's run sudo to run this with elevated permissions as root, so to speak. And I want to run /scripttest.sh. This time it works because execute permissions and read permissions are set for the current user, in this case root. So show IP info. Okay, 1. Looks good. We've got our IP addresses, IPv4, IPv6. FE80 is the local IPv6 address. The default gateway, the name server. Awesome. Enter. Number 2, show currently logged in username. Okay, root, because we ran this with sudo. Enter, 3 quit, and it takes us out. So there you go. That's a simple example of how to work with the Linux shell script and flag it as readable and executable so that it actually runs.